Imagine you ask an AI, show me the latest company data, and it accidentally spills out private customer records. Or worse, it shows manipulated facts from a hacked database. That's the danger hidden inside powerful AI systems called RAG. In this video, we'll explore why RAG, which makes AI smarter, can also make it vulnerable, and what emerging threats you must know about. First, what is Retrieval Augmented Generation RAG? RAG combines a large language model LLM with a retrieval system that fetches external documents or data at query time, effectively giving the model access to up-to-date, domain-specific knowledge, not just what it remembered during training. So when you ask a question, the system 1. Converts your query into a vector. 2. Searches a database of documents using embedding similarity up. 3. Picks the most relevant documents up. 4. Passes them to the LLM, which generates the answer using those documents as context. RAG solves some big issues with traditional LLM, because it pulls from external data. It reduces hallucinations by grounding answers in real documents. It lets models stay up to date without retraining, you just update the database. It supports domain-specific knowledge, e.g. corporate data, medical records, legal documents, enabling enterprise uses. But that retrieval adds complexity and new attack surfaces. Because RAG uses external data stores like vector databases, it no longer solely depends on what the LLM knows. That creates new vulnerabilities. The external database may contain sensitive data PII, corporate secrets that becomes exposed if not secured. The retrieval process itself can be manipulated or poisoned, which can mislead the LLM. The boundary between trusted data and untrusted user input becomes fuzzy, giving adversaries chances to exploit weaknesses via prompt or data injection. One of the biggest threats, sensitive data that sits in the RAG knowledge base, might be leaked by mistake or via attack. If access controls are weak, or if the system returns documents directly, private or regulated data PII, financial, medical could be exposed. Even worse, an attacker might query cleverly to extract confidential data through chaining queries or probing for unexpected output. Attackers can intentionally insert malicious or corrupt documents into the knowledge base used by RAG. This is called data poisoning. If the RAG system retrieves these malicious docs, the generated answers could be misleading, false, or manipulated, undermining trust and accuracy. In worst cases, poisoning can be crafted to only trigger under certain prompts, making it a stealthy backdoor. Hijack RAG and similar prompt injection/retrieval hijack attacks show that attackers can manipulate which documents the RAG system retrieves, or even make it return attacker-controlled content. By injecting malicious prompts or specially crafted queries, attackers may trick the system into exposing private data or giving incorrect, potentially harmful answers. This threat is especially potent if the system mixes user-provided content with internal knowledge indiscriminately. RAG systems rely on vector embeddings and numerical representations of text. But these embeddings are not immune to attacks. Adversaries may craft malicious embeddings or subtly tamper documents that appear semantically similar to legitimate content, tricking the retrieval system into returning them. This can subvert the retrieval logic without needing obvious suspicious documents, making attacks hard to detect. Recent research shows even the safety/guardrail mechanisms in RAG systems can be abused. For example, the host with his own petard, inducing guardrails to facilitate denial of service attacks on retrieval augmented generation of LLM, reveals that a minimal malicious document can trigger the system's guardrails, causing it to block or refuse legitimate queries, effectively a denial of service. In other words, protection built to prevent harmful output can itself become an attack vector. That shows how subtle and surprising the threats around RAG have become. More advanced attacks go beyond just poisoning or prompt injection. The Trojan RAG attack shows that adversaries can embed backdoors in RAG knowledge-based special trigger context pairs that, when matched, cause the RAG-powered LLM to behave maliciously, output harmful content, leak info, misinformation. Similarly, the Phantom attack demonstrates a two-stage optimization method, inserting a malicious document that's only retrieved when a specific trigger appears in a user's query, silently hijacking integrity without obvious signs. These threats are particularly disturbing because they survive typical testing. The system seems normal until a trigger activates the backdoor. Because RAG systems are increasingly used in sensitive domains, healthcare, legal, finance, the stakes are higher. A data leak or poisoning attack could expose PII, violate compliance, GDPR, or lead to fraudulent decisions. Moreover, attackers don't need direct access. Sometimes a compromised document in a shared or public knowledge base is enough to contaminate outputs. Thus, RAG security is not just a technical issue, it quickly becomes a matter of privacy, compliance and trust. Defending RAG systems is tricky because vulnerabilities appear at multiple layers: the vector database, embeddings, the retrieval logic, the LLM, and user input. Simple protection at one layer often isn't enough. For instance, even if you encrypt your database, embedding-based attacks or poison documents may still slip through. Also, as RAG systems evolve, multimodal RAG, real-time updates, dynamic content, the attack surface grows, so security needs to be baked in from design, not retrofitted. So what can you or your organization do to make RAG safer? 1. Use strict access controls and role-based permissions for who can read/modify the knowledge base. 2. Validate and sanitize documents before adding them. Data validation, embedding filtering. 3. Monitor retrieval behavior and usage logs. Watch for anomalous queries or repeated suspicious access. 4. Use encryption data at rest/in transit and apply zero-trust architecture for your RAG pipeline. 5. Periodically audit and purge outdated/unused documents to reduce the attack surface. If you're building or using a RAG-powered tool, don't treat RAG like just another AI trick. Treat it as a full-blown data system. Secure your databases, validate inputs, monitor access, and stay alert. Share this video with your team or community and ask, have we safeguarded our RAG pipeline properly? If you liked this video, subscribe and hit the bell for more deep dives into AI security and ethics.